about medians and altitudes of triangles. So technically 4 new vocab words. I really debated if we wanted to do construction first and then notes. I decided notes first and then we'll construct these using the patty paper to give you a little more reminders, a little hands-on, help you remember what's what. Alright, medians. Because back in pre-algebra, Math 7, you should have learned about mean, median, mode. Nod your heads. Do you remember those 3 things? Okay, do you remember what median stands for though? Yes, that literally is the same thing. I always think of it as the middle. So median, what you do, let's draw an acute triangle. Nice, easy, acute triangle. To find the medians, you've got to find the middle of each side. So let's just eyeball it. We're not going to pass out rulers and measure them out. So take one side, eyeball it, put a little midpoint in the middle. But if that's the middle, make sure you have little symbols. That's congruent to that. And then do the same thing for the other 2 sides. So just eyeball it, find the middle, maybe like right there, and then put in your congruent symbols if that's the midpoint, this piece congruent to that piece. Same with the last side, just eyeball it for today. Put in your symbols, that's congruent to that. Median, middle. Find the middle of the sides first. Now in order to do the median of a triangle, what you do is you go from a vertex and go to the midpoint of the opposite side. That green line right there is a median. Same thing for the other 2 vertices. So go from the vertex to the midpoint of the opposite side. That red segment is a median. Last, go from the vertex to the midpoint of the opposite side. Those 3 lines are medians. So let's get a picture in there. Let's also write it in words. So remind yourself, medians go from a vertex to the midpoint of the opposite side. Tyler, did you have a question?
Yeah, are those the angle bisectors? Or?
Okay, his question is, are these angle bisectors? What do you guys think? Not necessarily. Could they be angle bisectors? We could add it in and measure it. They could be angle bisectors, but just for the median, Tyler, all you're focused on is cutting the side in half, not the angles. It's a great question. Okay. Median and centroid go together. This is the only trick I have to help you remember. I think median, the second letter is an E, centroid, the second letter is an E. These go together. So the centroid is where they all meet, right there, the point of concurrency. So centroid, you've got to draw your medians first, and then where they all meet, that's your centroid. So like we learned yesterday, point of concurrency, the point of concurrency of the medians, where they all meet. Median, centroid, kind of the same thing, right? Draw 3 medians, that gives you the centroid. Just gotta remember those 2 are coupled together. Okay, the next new thing, altitude. Let's do the same thing. Let's do another acute triangle. So draw yourself an acute triangle. Make mine a little bit bigger this time. Okay, altitude. When I think of altitude, I think of mountains. When I climb a mountain, I'm going up, right? It's a height. Altitude is the height of something. So this is literally the height of the triangle. So what you do to find the altitude is you go from a vertex and you have to go 90 degrees down. That's it. Nothing about bisecting, nothing about midpoints. It's just straight up from a vertex 90 degrees to the opposite side. I kind of have a hard time eyeballing these ones. It's nice when we construct it because we can use our rulers, the 90-degree part on our ruler. Okay, so this side to this side, I got to think, where is it going to make a nice T? Maybe 90 degrees. I don't know. I kind of think it's steep, like right there. I don't know. Does that look 90 degrees? And then remember, I taught you this yesterday. Once you have 2 and you're just sketching it, just remind yourself, well, they've all got to be at the same point. So I'm going to use that to my advantage. Altitude, go from one vertex to the opposite side. Just has to be 90 degrees. So there's our picture. Let's write it in words too. Again, from a vertex, 90 degrees to the other side. I would say, if I had to vote which one is the toughest to construct, I'd say altitudes. Those can be really hard to construct because, think about this, medians. Do you think medians are always going to be inside the triangle sometimes or never? Think of what you do to create the median. You go from a vertex to the opposite side, right? Do you think that's always going to stay inside? Absolutely. Okay, altitudes, what do you think about this one though? Do you think these ones will stay inside? No, I think outside stuff is going to be hard. Like for example, right? Triangles, rough. We'll construct it and I'll show you. Okay, orthocenter. Anybody want to guess what orthocenter is? Totally. It's where the altitudes meet. Orthocenter, I don't have any tricks for you on that one. No, I think you're on. Altitudes, go with orthocenters. Orthocenters is the point of concurrency right here of the altitudes. Now remember, we have our vocab quiz tomorrow. These are fair games, so definitely study these tonight. Okay, the rest of our lesson today, we're just going to be using medians, altitudes. How are they used? Okay, there's something super interesting about medians. So here we go. I'm a picture person, obviously. So I like to highlight stuff in the picture. So here we go. What this theorem is saying, the concurrency of medians, if you go from AP right here, do you remember what this part is called? Letter P, do you remember the vocab word? Perfect. Let's circle it in our notes. That's the centroid. So if you go from a vertex to the centroid, this piece is 2/3 of the whole thing, of the whole blue. So this little purple part is just 1/3 of it. Always. Isn't that crazy? That always happens, as long as you've constructed the median correctly. So let's put this into perspective. If this piece is, how about 3? Do you know what this red piece would be? Yes, good job. That'd be 6. That's like one piece. Put 2 of those pieces together. The whole thing would be, yeah, whole thing would be 9. Let's do another one. I'm seeing confused looks. Let's see. So there's our red. Purple was a little bit, right? All right, what if this piece right here was 10? If the red piece is 10, what's the little blue piece? Yes. Cut 10 in half, because that's 2 of the pieces. So this would have to be 5. I always think of it like this. In my head, I think of it as 3 separate pieces. We need one more piece, right? So if this whole thing is 10, cut in half, that'd be 5, that'd be 5, this would have to be 5. That's how I do it. I'm a picture person. Okay, if the whole thing was, I don't know, what if the whole thing is 15? The whole thing is 15, this whole thing is 15. How much is this part worth? Totally. This part, 5. Same thing, right? Only backwards? We'll practice that a little bit more. Okay, the last part of this, it's got the theorem 5.8, concurrency of altitudes. What it's trying to say is, guys, altitudes are always going to intersect. Always, always. As long as you construct them right. Now look at this. We're eventually going to be constructing this. So we've got this triangle right here. They're saying this right here is the point of concurrency. All right, is that meaning inside, outside, or on the triangle? Big time outside. So we gotta be careful that we don't make our pictures too big. It's rough. Okay, let's see what's next. Okay, we talked about. So ours is the centroid, so that means these are medians. Guys, let's add into our picture. If this is the centroid, we need symbols on this triangle. So let's put, if that's the centroid, that means this is congruent to this. This piece is congruent to that piece. That piece is congruent to that piece. Just with centroid, can we add anything else to this picture?
Yeah.
No, it's just the centroid. All we know is that those are the medians, the midpoints. Okay, so now we can put SR, where is it? This piece right here is 16. So now you're going to find RB, that little piece, and then the whole thing. Okay, ready, set, go. Try it, try it. Okay, if you're struggling with this, break it into pieces. I think this whole thing is 16. So if this whole thing is 16, this is from S to R, and then there's RB. If this is 16, what's this little piece? Has to be. And then this little piece is 8. So this little piece is, there you go. So RB right here has to be 8. Put them all together, what's SV? Guys, I'm curious, how many of you got that? How many of you are picking up this there. Does that make sense to you? Okay, sweet. Alright, let's move on. Okay, this one. Check it. If there's something on a grid, can you be nice to yourself every single time? Yes, please, please be nice to yourself. If you notice something, use the grid to your advantage. So it's saying find the coordinates of the centroid. So we've got to find like where all the medians are meeting. So let's find the midpoints first. So the midpoint of this line right here, isn't it? Do you agree J is right smack in the middle? Well, if we have that coordinate right here, just count it out. What is that? Is it 5, 1? Yeah? We can just count out what's right on the grid. Done. Let's put in our symbols. So this is congruent to this. All right. So we know that a median comes from this vertex down. All right, let's find the middle, the midpoint of this line. Again, can you eyeball that? Where do you think the midpoint is on that? I agree. It's got to be H, right? So we put a dot right there. There's our midpoint. But what are the coordinates? Perfect. 7, 4. Put in your symbols. This is congruent to this. Okay, draw in your median. Stay with us. So go from the vertex to the median. Okay, do the last one. You got this. You got this. Sketch it, draw it. Something happens. It's on the grid. It's super nice. Okay, it looks like this midpoint would be G. So that's the point over 3, 4. So add in your symbols. Draw in your median from a vertex to the midpoint. Check it, you just created the centroid. Centroid is where all 3 of those are meeting. The purple, the green, the red. Here's our centroid. Guys, is that right on a point on our graph? Totally. What is the point? Describe it. Done. So nice that we had a grid, right? So final answer, find the coordinates of the centroid, 5, 3. Use the graph to your advantage every time. Okay, let's go to the next part. Reflip pages, yep. Now the top part of the next page is about construction. Guys, we're gonna pause on that and come to it later. Plus it would be kind of hard to do it in your notebooks because we'll use our padding paper so we can fold it. So skip that next part, let's go to this. T is the centroid, centroid is for the medians. So right here, emphasize T, that's the centroid. Add in the symbols, start practicing with the symbols. If that's the centroid, the only thing we know is that RU is congruent to US. This piece congruent to this piece. This piece congruent to this piece. Add it in, add it in. It's good practice with the medians. Okay, next we know that this little guy is 7. That's it. Can you figure out the big piece and the whole thing? Try it. Good luck. Try it, try it. Okay, nice and loud. Guys, what did you get for QU? The whole median. What is it? 21. Hey, good job. And then what's the piece that's broken, the QT? What's that? Good job. Just remember, if you have a hard time in the picture, bring it back, break it up. 7, this would have to be 7 and 7. So this piece, 14, whole thing, 21. Curious, how many of you got that? Let me see. Good job, good job.